Hi again. In this video, I will be solving two simple examples related to Kirchhoff rules. But as a start, I thought I might revise what I discussed in the previous video quickly as a reminder. So here on top, I wrote the direction of traverse from A to B. So I am going through this resistor from the point A to point B. Now my current direction is going also from A to B. So if I want to find the voltage difference through this resistor, it will be negative IR. It will be negative IR because simply here is the highest, here is the lowest, and that will be the negative voltage across this resistor. The same scenario with the battery down here. If I have the travel direction or the traverse from A to B, or the loop direction, whatever you want to call it, from A through the battery to B, and I'm trying to find the voltage across the battery, it will be positive, the voltage of the battery. Let's try the other way around. I'm still going from A to B here through the resistor, but the current is opposite my traverse direction or my travel direction or my loop direction. In this case, the positive, the negative, or the high voltage, it's at this end, and the negative or the lower voltage on the other end here. So the voltage across this resistor will be a positive IR, okay? Because my travel direction, I was entering the resistor from the negative side, getting out with the positive side. So I will end with a high voltage. Well, that's why it is a positive IR. Let's do the same thing through the battery. I am going through the battery from A to B, okay? But the battery as a voltage, it is the other way around. The positive is here, the negative here. So when I entered the battery and went out through the battery, I am getting out with the negative. That's why it is a negative voltage. That's what we are going to practice in the next two simple examples. The idea is just to practice to control the loop direction and how we can follow the formula of the loop rules from Kirchhoff's rules. Now, in this example here, I chose to have only one loop, nothing else. So not that big circuit or a complex circuit, it's just one loop circuit. I know you could solve it to find the current through this circuit by following what we learned in the resistors connected in series. They are connected in series. You add them up, 1 plus 2 plus 3. That will give you the total resistance in the circuit, and you have the voltage, you can find the current. But the question asking you to use Kirchhoff rules to determine the current through this loop. So what I'll do, the question already identify the direction of the current. So the current is going to be this way, okay, and this way and through this resistor. That's the current direction. It's clockwise. Now what I'll do, I will assume my loop direction also will be going the same way. So that's my loop direction. Okay, I can call this is A, B, C, D. It's fine. So my loop will be A, B, C, D, and coming back to A. That's my loop, which is clockwise, right? So what I'll do, I will start from the point A, going through the wire to B. There is nothing. Now here we go. From B to C, I am crossing the battery, and I am entering the battery with my loop direction from the negative side, coming out with the positive side. So this will give me a positive 12 volt. Now through the resistor, let's call this one as R1. Let's change the color to make it more clear. This one is R1, this is R2, and this one is R3. Maybe that will help us to simplify things. Now I'm going through resistor 1. Okay, now through resistor 1, this is the positive, that's negative. Also here will be positive, this is negative. Here again it is a positive, and here is negative. I'm following the current direction. Now when I apply the loop rules, when I go through resistor 1, I am entering from the positive side going out with the negative side or the lower voltage, which means I will have the voltage across this resistor exactly following the rules we did here. Okay, so I am going my loop direction and the current direction the same. That means it is a negative I R1. The same scenario going through resistor 2, I am going with the same direction of the current. I am coming from high voltage to low voltage. Once again, it's a negative IR2. Through resistor 3, coming from high voltage to low voltage, it's a negative IR3. And that's it, nothing else. That's the total voltage for one loop. Now, as you can see, we can say, right, it is a positive 12 minus I as a common factor, R1 plus R2 plus R3, that's equals 0. That's a positive 12 minus 1 plus 2 plus 3. These are the values of these resistors, and it will give me 6 I, that's equal 0. It's a very simple equation with one unknown. The current will be 12 divided by 6, and it is 2 ampere. So that's the total current through this through this circuit, or through any of these resistors as they are connected in series for this circuit, following Kirchhoff rules. All right. Now that's one example. Let's try another example where it is still one loop, again to practice the loop formula or the loop rules of Kirchhoff rules. Now what I'll do here, I'll do this thing. I will say, all right, let's assume the current is going through this circuit this way. It's a counter clockwise. Okay, that's my current. So I can do quickly this. I'll say I can change the whole scenario. I know it's in the example here, it's saying this is the positive, this is the negative. I want to try to change that by force. I just want to try to practice more of this. And so I'm trying to reverse what it was the default or the direction of current. We could do that. We said that before. I can assume the current direction to be in a certain direction I want it. So I would love to have it like this way, not the way it's been designed before. Now also I want to do my loop direction to be this way. That's my loop. It is clockwise, but the current is going counterclockwise. Let's see, this assumption we did, is it going to affect the value of the current? Or the sign will be getting at the end of the question? Let's practice. So my loop, I will be taking loop 1, 2, 3, 4, and back to 1, definitely. So I will go through my battery. That will give me a positive 45. Okay. Now plus or minus, let's figure it out through resistor 1. I am entering resistor 1 from low voltage, getting out with a high voltage. So that will be definitely a positive I R1, because my loop direction is opposite to the current. We could say that as well. Through R2, the same scenario, I R2, and for the last resistor, it is the current through resistor 3, and that will be all equal 0. That's it. Once again, it is 45 plus I, and these resistors as a common factor, 5 kilo ohm plus 10 kilo ohm plus 7.5 kilo ohm, all equals 0. Okay, that will give me 45 plus 22.5 kilo ohm times the current. Let's do this. And the current will be minus 45 divided on a 22.5 10 to the power 3. That will give me minus 2 milliamps. All right. Now, what does this negatives mean? The negative here means that my assumption for the current direction was opposite to where it was supposed to be. Originally, it was the other way around when I recorrect all these pluses and minuses. So if I use the same default one before, I will end with a positive 2 milliamps. But it's good to learn or practice that it is fine to get the current is negative, and that negative telling you that you picked the direction of the current opposite to what it's supposed to be. Okay, I hope you find this video useful, and we'll see you again with another Kirchhoff rules example. Thank you.